Hello everyone, welcome to today's webinar, The Intelligent Mind, part of our ESG Showcase series. I'm Sam Sakasiris, the Austmine Membership Manager for WA, and I'm your host today. Before we begin, on behalf of Austmine and all of today's presenting companies, I'd like to acknowledge that I'm hosting the webinar from the lands of the Whadjuk Noongar people. We acknowledge the traditional custodians of the various lands on which we meet today and recognise the Aboriginal and Torres Strait Islander people attending this webinar. The ESG Showcase series is meant to provide our members a way to showcase their solutions while sharing valuable insights to help overcome key ESG challenges. The ESG webinar series covers various topics and highlights the innovative solutions and technologies that met set to mining's sustainable future. Today we continue this series with the Intelligent Mine, delving into technologies and solutions around innovations in machine learning, digital twins, predictive analytics, and simulation tools for mine operations, just to name a few. We have 5 industry-leading member companies sharing their technology and innovation success stories. Joining us to share their expertise are Michel Bachoir from Aspentech, Carl Snowling and Melissa Gibbs of PIAGO, Peter Van Schalkwijk from XM Pro, Alvaro Alesso from Aviva, and Nadine Rabu from Idoba. The format today will be will include a short presentation by each of the presenters, followed by a Q&A session after the conclusion. If you have a question for any of the presenters throughout the webinar, please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note that their name in your question. We will endeavour to get to as many questions as we possibly can. This webinar is being recorded and it will be shared with all attendees. So that's the conclusion of my welcome and introductions. So without any further ado, I'd like to welcome our first presenter, which is Michel Bachoir, Principal Solution Consultant from Aspentech.
Good day, everyone. Thank you for joining us today. I hope you'll find our session informative and captivating. Today, I will be introducing you to MTEL, Aspentech Prescriptive Maintenance Solution. Our primary objective is to illustrate how MTEL effectively minimizes equipment failures, showcasing its user-friendliness, ease of deployment, and sustainment. We are not going to focus on fancy dashboards. Instead, we will show how MTEL engine works and what sets this technology apart from others. Okay. But first, I will quickly introduce Aspentech. Aspentech is the world leader in asset optimization for capital-intensive industries. We are a 42-year-old company with over 3,000 customers around the world. Over the years, we have developed technologies for oil and gas, petrochemical and chemical industries. And in the last few years, we are bringing those advanced technologies into the mining sector. 82%. Why is this number important? Our analysis of Boston suggests that 82% or more of damage to equipment is not caused by normal wear and tear, but is process-induced when equipment is operated outside design specifications. This causes equipment to fail randomly. However, the spend is mostly on wear and tear or on the standard maintenance practices. These practices cannot find those errant conditions, no matter how much machines are inspected and serviced. Furthermore, it has been suggested that 63% of maintenance is unnecessary and can cause more damage if the equipment was left untouched. Another way of visualizing this is by looking at this PF curve. The idea is to catch the problem before it reaches the P point or the point of no return, as I call it. Having a stable operation will minimize equipment breakdown due to process upsets. How MTEL can alert you that these issues are happening? MTEL uses agents. Agents are automated software components that perform machine learning. They look for specific patterns in data that show normal and failure behaviors. They will alert when changes in these behaviors occur. For example, we have the anomaly agent, which learns what is normal and alerts when the sensor's pattern behavior is outside this normal. On the other hand, we have the failure agent that learns a specific signature and provides early warning when the pattern is identified. So how are these agents created? MTEL uses machine sensors, process sensors, as well as upstream sensors in a holistic approach. Then MTEL gives you the flexibility to create group of sensors to target specific areas of your equipment, such as the motor or the cylinders, or even equipment upstream. With those groups, you can create and train failure agents to protect your equipment from various known failure modes, and anomaly agents to protect against any process upsets and never seen before failure modes. So this is the approach of MTEL. MTEL amalgamates sensor data to create a probability waveform, as you see in the left. This waveform shows the probability of failure at any point in time. So I'm going to, with this waveform, I will quickly explain how agents are created to see how easy it is. First, the wizard identifies all offline conditions. Then MTEL overlays all recorded events that cause a failure in the past. For each of these events of failure modes, MTEL creates failure agents to watch for specific signatures. These signatures are multivariate and behavioral patterns that humans cannot see that lead to recorded events. Then with all not recorded events or unknown faults shown as spikes, MTEL labels those events to remove all abnormal conditions. Then after removing offline, failure, and unknown conditions, what remains is the purest form of normal behavior. With this, these are normal behavior can include seasonal conditions, operating campaign, batches, startups, etc. With this data, MTEL will create an anomaly agent that will monitor and alert when the equipment is outside of normal operating conditions. Once the alert is deployed, it will monitor live feeds in real time. So if the agent detects an abnormal behavior, it creates an alert requesting an inspection, providing prescriptive guidance. This prescriptive guidance is provided through sensor contribution and an FME library. If after the inspection it is determined that the abnormal behavior is a new operating state, the user can close the alert as new normal, and then the pattern is added automatically to the normal baseline and no similar false alerts will occur. This literally takes just a second, so it will adapt and will learn as time passes by. However, if a new failure is identified, a failure agent can be created. This improves the accuracy of the agents, and also improves the protection of the assets. In predictive analytics, you may have heard about models. Models focus on the equipment and can only see degradation when it has already started. You may recall the P point in the PF curve. At that point in time, there is not much improvement from mainstream condition monitoring techniques. Models also require extensive calibration every time there is a process or operational change. And most of the time, this calibration needs extensive data science knowledge. On the other hand, MTEL focuses on the failure pattern, which provides much more accuracy and longer lead time. You will not only be able to know of an incoming failure, but you may avoid the failure altogether. This may sound a bit complicated. However, MTEL uses a technology that allows anyone on site to be able to create agents. It democratizes the use of artificial intelligence in your mine site. Most vendors that claim similar capability charge per model, asset, or tag. MTEL is offered as a site license. It means that you can cover all your assets within a short period of time with the same personnel and the infrastructure that you currently have. So in summary, MTEL learns from historical patterns and uses machine learning and neural networks. It will provide the longest lead time and highest accuracy with minimum false alerts, which is very important for the user. If you have too many alerts, the user may not pay attention to them. It is agnostic because it focuses on data. It can be used to static, rotating, or mobile equipment in any industry and any failure mode. As mentioned before, it's a site license, so you have full coverage with no extra cost, no cost per tag, model, or asset. It's very easy to use. You can deploy the agents very quickly, and it complete ownership to the customer. No data science knowledge required. Training will only take 3 days. You can roll out very quickly in hundreds of assets and do even transfer learning from one asset to a similar asset. The agents will self-learn, so it means they will improve and adapt to process operation changes without recurring to extra resources. And it will monitor in real time. So only when there is an alert or an alert, you will receive an email or an SMS, or you can see that in the dashboard. So in mining and metals, we have applied this in MTEL in this asset, which, however, this list is not exhaustive. And just as a use case to finalize this, MTEL has been deployed in evolution mining. And the initial deployment it was done by Aspentech on 10 assets in just 3 months. And then the Mangari team scaled to 31 assets and created more than 100 agents. In terms of sustainment, the Mangari team worked on fine-tuning the agents based on equipment and operational changes. They monitor themselves and manage the entire alert management workflow. Currently, the alerts are acknowledged in less than half a day. And then you see the results in the first 4 months. This is what they have achieved in terms of ROI. And this is the last 15 months. Just to say that all this value capture was provided by the Mangari team. However, I want to also stress that Aspentech supported the team through the whole process. And these are some of the customers that have deployed MTEL in the majority of them in more than one site. If you have more if you want more information, please don't hesitate to reach out. Thank you.
Thanks very much, Michel. Next up, I'd like to welcome Carl Snowling and Melissa Gibbs of PIAGO. You may begin your presentation.
Thanks, Sam. Hello, everybody, and thank you again for your time. As mentioned, I'm Melissa Gibbs, Strategic Account Exec at PIAGO, and I'm joined by our Director of Operations, Carl Snowling. I think the best way to place what we do at PIAGO with how a mine or mining company can act in an intelligent way is initially to draw a line between the two main players in the game. Player one being the mining organisation and site itself, and player two being the contractor companies that contract into those mines. So we're creating an ecosystem of contractor management and project onboarding solutions that are currently adopted by 18 different clients of ours. Now, these range from large tier one mining companies like Glencore, Coal Australia, to the contracting companies that supply people and equipment to the mining industry all around Australia. So whilst the research shows that the core of the mining industry, being the mine sites and the large mining companies, are at the forefront of embracing technology, there's a real disconnect with the adoption levels of technology in the smaller mining companies and those that contract into the mines. So this is why PIAGO is creating an ecosystem of platforms that make it easy for the mining companies and contracting companies to interact. So the studies show that these smaller companies identify investing in technology as being a significant business risk and more of a business expense rather than a revenue driver. Whereas, interestingly, the mining companies that embrace the digitalization trends are improving business productivity, reduce costs significantly, and see an overall really positive transformational effect on their practices. Here at PIAGO, our suite of products aims to make that investment and digital transformation seamless. So I'm going to pass you over now to Carl, our Director of Operations, who's going to run through our product ecosystem for you.
Thanks, Mel. So as well as striving to improve the intelligence of mines and mining, at PIAGO, we're striving to provide software to help make an intelligent industry. So to paint a picture of what I mean and where we're heading, I'll just first provide some background on our journey to date. So in 2017, we initiated a pilot program with Glencore across 2 of their sites in Queensland with the new induction and onboarding platform. One that incorporated the induction process, mandatory and elective document submission and approval, e-learning and event management, all online. By 2019, we expanded the program to additional locations across Australia. And by 2020, the project had grown exponentially, achieving milestones such as 27,000 workers inducted and inductions completed, of which incorporated 200,000 submitted documents viewed and processed by our client in those applications. And then those workers went on to perform over 220,000 completed online courses. So this platform we now call is GoSite Approved. This is our enterprise platform that enables mining and construction companies to streamline workers' induction. In other words, get them approved onto site. As we rolled out the program for Glencore, we participated in several contractor forums with the industry and received great feedback. In speaking with the companies in attendance at those forums, there was a recurring theme. Whilst this system would be great for their workers being inducted at a Glencore site, they also needed a system that was theirs to manage and maintain their workers across all of their client sites. So starting in 2022, we set out to develop a new standalone product tailored for these contractors and labour hire companies to address these needs. The name GoSite Ready comes from ensuring that workers or equipment are ready and compliant at all times to attend the site. This product offers comprehensive features for managing employee and equipment competency management, role-based training needs analysis and site compliance management, scheduled reporting and competency expiry alerting, rosters and job scheduling, and communication via email and SMS. So we aim to make the process as simple as possible for certifications, driver's license, medicals, all of those encompassed, that are updated in their individual GoSite Ready systems to be instantly sent on for review to the client sites that their worker or that worker attends. We're very close to releasing part 1 of our integrated ecosystem, where we'll launch what we call our one-click submission feature, allowing easy updates across multiple client systems. This is just the first in a number of integrations we'll be rolling out that will save time and money and eliminate human errors that result in lost production of workers for both the contracting company and their clients. For our GoSite Ready clients that also need to update other non-PIAGO integrated systems, we've also provided the ability to save external links for quick access to browse those systems too. So looking ahead to 2024, we're excited about introducing what we call the PIAGO Marketplace. So this is an integrated platform allowing for seamless job postings and talent searches within the ecosystem. So these postings can be between any member of the PIAGO ecosystem and marketplace. So whether you're a large miner or a small contractor, you can operate as a standalone entity with that security, but also choose to integrate seamlessly within the industry. This is part of our broader vision for an integrated industry ecosystem. Thank you very much. We welcome you to reach out via our website link below. I know I've only touched on a bit of that there, but there's a lot of additional features we have in our ecosystem. We very much appreciate being part of today's webinar. So thank you.
Thank you very much, Carl and Melissa. That was very informative. Next up, I'd like to invite Peter van Schalkwyk, the CEO of XM Pro. The audience is yours, Peter.
Thank you, Sam. Let me just get this to move. Oh, there we are. Too far, too quick. Thank you very much. I'm Peter van Schalkwyk. I'm the CEO of XM Pro, and outside of that, of XM Pro, I'm also the chair for the Natural Resources Working Group inside the Digital Twin Consortium. XM Pro started in Sydney in 2009, and as you can see from the industries that we serve, we come from an engineering background, so pretty much in the asset-intensive industries that we focus. We're also very proud to be the only Australian vendor recently named by Gartner as a technology innovator for digital twins, which is the focus of what we'll talk about today. As I said, the only Australian organization to do that. In terms of where our software and applications run, it's not just at the mines and the operators, but also in the broader ecosystem. This is Weir Minerals, one of our clients, and together with Aviva OSI Soft, this is the remote operation center. That's an engineer that helps with real-time decision support for clients using their system. Intelligent mining for us is all about better decision making, as the previous slide said. So better decisions faster is the key for improving not just ESG, but everything around sustainable mining. And traditionally, we focused on dashboards, business intelligence, condition monitoring, very basic decision support. We see more and more decision augmentation with tools like AI, prescriptive recommendations, front-running simulations. And as we move forward, we also see decision automation where we can operate by wire in a safe envelope like we fly by wire or drive by wire. All of this together is the decision intelligence that you can provide with things like intelligent digital twins. And when you get this right, this is a soft rock miner in Canada, wanted to reduce long conveyor downtime by 30%. One of the problems that they wanted to address, 80 kilometers of underground conveyor, and over a 5-month period they reduced, or they had an additional 44,000 product tons. The digital twin that we created was not like a high fidelity, very complex model. This is almost like a London Tube model, but you can, or view of the conveyors as you stand on the surface and look down. You can see the impact of providing real-time event intelligence or decision intelligence and enabling subject matter experts to be able to act on recommendations. The key thing with this was it was piloted at the first mine and then rolled out, and that's the whole benefit of a digital twin approach, which is all model based. So it's not a single, but I can take the same approach to borers, pumps, crushers, fans, and then start going back and adding more capability, make it more composable, which I'll talk about in a minute, and then even add more capability like computer vision on conveyors, combining these so that I create a digital twin of underground, if I've got the conveyors, borers, hoists, and those kind of things put together. So for us, it's about think big, start small, scale fast in all of this. It's not just at the operational level. Sometimes a GM of a mine would want to see something in terms of the operations in a very similar way. And someone's moving my slides. It's not me. So I'll just go back one slide. So a GM of a mine may want to. There's definitely someone moving slides around. So it could be at operational level as well. So I can see, for example, that I have issues on a crusher, and I can drill down to that. So going from an operations level into a planning phase where I can look at end of life. And not just that information, but combine it with work orders and other relevant information that might be applicable to it. So our view is not on just a single point solution that addresses a specific area, but with digital twins, and the whole value of digital twins is that you can do this across the whole value chain, across key areas. And you can see these are all use case driven. There might be templates, accelerators, blueprints, and things that we provide, but there are also unique areas where you want to use the same approach and build that. And those are what all the X's are. They are specific bad actors or specific areas, specifically around ESG and other newer topics that require that. So for us, the way to do this is through what we call intelligent digital twins. And they are typically integrated, intelligent, interactive, and composable, like the kids' Lego bricks. You can build the blocks together. That's what makes an intelligent digital twin. And if I look at how we do that inside XMPro, we start off with what we call our data stream designer in step 1, which is where we do all the integration. We can add intelligence either in step 2 or step 3 with AI and our application designer, and also recommendations where we close the loop on what needs to happen. So just very briefly, this is where 80% of the work happens for us. This is a visual way to build out those real-time data streams, connect, make it integrated. You can see agents on the left-hand side where I bring in either listening to certain data sources where I can wrangle all the purple items, the red items, bringing in context like make, model. I can do calculations, update existing or external systems, embed AI, and also create or run recommendation rules to identify how to improve this. Again, this is 80% of the work that happens underneath the surface of an intelligent digital twin, and it's all driven in a visual way. On the AI side, Jupyter Notebooks embedded, and I can bring intelligence. This is wired into our data streams, so it makes it really easy to do some of the specific analytics. When we look at the front end side of things and we want to create nice visualization, this is Unity, but also in the middle with a pump there. But on the Copilot side of things, you can bring generative AI, large language models that are specifically trained on your assets, your information, and you can see that on the right-hand side. And it's not just these newer type things like fancy graphics and AI, but also on that same one, I could have maintenance schedules, maintenance history, work order information, all the decision intelligence that I need around what do I need to do next, and how can I best respond to something. And that's where recommendations come in. So now I have a recommendation on terms of what to do next. I can do triage, I can see how many times, and also I can mark false positives, which is a really important part of the whole thing. So in closing, for us, it's about think big, start small, scale fast. You can build some pretty comprehensive solutions, but it's all driven in order to create intelligent minds. It's not about point solutions, but it's about making it integrated, intelligent, interactive, and through all of that, help you to operate your mind at its full potential. And with that, I'll hand over to you, Sam.
Thank you very much, Peter. Great presentation. Next up, I would like to welcome Alvaro Alesso, the product sales leader at Aviva. Take it away, Alvaro.
Great. I'm going to start moving the slides over. That's your final slide. That's my face there. Hi, you guys. Thank you for joining us. Today, I'm going to be talking about what the intelligent mind is from the Aviva perspective, with a focus on Aviva Predictive Analytics as one of our key solutions. So first of all, a glimpse into Aviva. So Aviva is a global leader in industrial software. We provide industrial on-prem, hybrid, and cloud platforms and applications that enable the business we work with to harness the power of their information and improve collaboration. We have over 20,000 industrial customers in over 100 countries with 2 million licenses installed. We enable teams to engineer efficiently, optimize operation, which help them drive growth and sustainability. We have over 50 years of innovation, and Aviva holds a leading market position in diverse market and industrial software sectors worldwide. When we're thinking about mining specifically, we can see there that 10 of the 10 top leading global mining companies use many products from Aviva. We are in over 400 mining sites around the world. And these companies have been using our Aviva systems to drive hundreds of millions of dollars of value from solutions like production management, the PI system, predictive analytics, mobile operator solutions, engineering solutions such as asset information management. And we see that most customers are looking for an end-to-end solution, and we have over 300 innovative partners that can help us achieve that. Most customers that we work with get value from 5 to 6 business value areas, from process productivity, where they need to monitoring process and asset health in real time, from energy and water management, reducing consumables, fuel, from asset reliability that we're going to touch in a second, other ESG considerations such as governance, compliance, regulation, quality assurance, or just plain KPIs and reporting from an operation perspective or even financial perspective. So when we talk about the intelligent mine, we're thinking about all these areas, but today particularly, we're going to focus on the application of some of our solutions to the asset reliability space. So we see customers generally in a journey similar to what we were seeing a second ago around the DIPF curve, depending on the level of instrumentation of their assets, the level of sophistication of the asset strategy, moving from reactive, where it's a break and fix mentality, down to preventative, where the maintenance routines are dictated by time and usage based. And then we're starting to get into the real-time maintenance practices such as condition-based, where we see certain rules being evaluated and from those rules generating diagnostics on the machine that allows us to schedule planned maintenance, or even going further, getting into the predictive and prescriptive part where we need more than just real-time data. We need diagnostic and understanding of the failure modes, prescriptive actions tied to those failure modes, and understanding of the asset data model, the taxonomy. So that's when things get a bit complicated. So when we talk about these kind of solutions and dealing with OT data, we need to think about a data platform. And for Aviva, that is the PI system. And the PI system is this real-time OT data platform that allows us to turn data into decision-ready information. We're going to have, of course, our historian piece, which is the data archive, when we store and access these massive amounts of data. And then we're going to have different components that allow us to enrich that data right there at that layer. Number one, the asset framework that allows us to set up and add subject matter expert knowledge to that data, asset structures, metadata, serial numbers, manufacturers, everything that is going to help us for all the other applications we want to connect to this source. Then we're going to have analytics where we can transform that data into actionable KPIs that address the problems and the areas where we find value. We're going to have event frames which help us pinpoint those, start and end times of where certain conditions are met, and finally notifications where we get those alerts turned into actions. So when we're talking about predictive analytics, we're talking about an ML AI enabled layer that sits on top of that system. Could be the PI system, could be another historian for that case, where we're making use of that historical data. We're storing predictive value, we're storing health indications so we can do further analytics with it. We're making use of that asset framework hierarchy and the data taxonomy and making use of all that tag mapping that we've done before and unifying that namespace across my operations. We're enhancing the analytics through reliability, process, and performance analytics with ML-enabled analytics. We're using the event frames that are generated on that layer, on that core layer, to better understand when is my asset underperforming and taking those training data sets to help configure predictive models. And also we're enhancing notifications with advanced early warning predictions. So what is predictive analytics? It's essentially a no-code AI and machine learning application for failure detection, performance degradation for business critical equipment. It's meant to be used by subject matter experts with two clients. One is where I process my alerts. The other one where I configure my models, has the ability to play back on existing data so I can validate my models before I deploy them. And more importantly, has an advanced case management tool that allows me to take action and have conversations internally with my teams. So I would start with a unique view. In this case, is the PI vision and telling me or showing me a view of my operations. I click on, in this case, a SAG mill where I can see operational KPIs right there. I can see actual and predicted values from these tags. And I have already a machine learning predictive analytics view on the bottom right part, where I can see the overall predictive health score increasing over the past 4 hours. So this gives me the first alert where I need to go to predictive analytics. Has a high performance integration with it, just takes me to that page and I can start processing these alerts right away. I'm going to see an asset health degradation score, what we call overall model residual, going up. This little chart here tells me what are the sensors that are the heaviest contributors to that anomaly. I can see here that I'm having a temperature issue with my drive end and my non-drive end. All of that data being taken from Asset Framework, as we saw before. I can deep dive in sensor behavior to understand whether I have a sensor issue, whether I have a problem across all my tags. I can quickly visually compare before I realize that I have a specific problem, right? A diagnostic. And this is where the tool gets prescriptive. It's showing me what is the most likelihood, the likelihood of the occurrence of each failing mode. When I click there, it takes me to the second tab, the faults view, where I can see a description of the problem, the next steps, prescriptive steps, and I can even forecast what's the likelihood of occurrence of this problem in a certain time frame. I just grab the tag and start simulating, and I can see there's a very high probability of occurrence within a day. So this tells me I have to take action. So this is when the case management tool comes into play. I just go generate a case. As a monitoring analyst, I know that this is an equipment problem. I'm going to assign it to a maintenance team on site. I'm going to describe it, put a title to it, maybe add and attach a snapshot of the trends. I can attach documents, CSV files to facilitate further investigation by the SMEs on site. I'm going to type here what I need, assign it to someone, and then when I save, creates a predictive alert that can be reached from site. I can even connect it with my ERP, EAM system, and the people on site will see exactly what we're seeing on screen. A list of predictive alerts, reminding that the machine is still working, and this is where they're able to provide feedback. So we've done this for many customers around the world, even here in Australia and even in the mining industry. Rio Tinto is one of those where we've deployed a program of models that is serving now many plants, more than 300 assets, creating savings in the order of millions of dollars, SAG mill motor failures, performance issues with pumps, and the ability to templatize these models is what's really helped Rio Tinto deploy this at scale. So with that, I conclude my presentation today. Please feel free to reach out for any question. Thank you.
Thank you very much, Alvaro. Fantastic presentation. To finish off the presentations, I'd like to now welcome Nadine Rabu. She's a Senior Consultant, Strategy and Sustainability at idoba. Nadine, the floor is yours.
Thank you, Sam. Well, hello, everyone, and thank you for staying until the end. As you just heard, my name is Nadine Rabu. I'm a Senior Consultant in Strategy and Sustainability with idoba. Although idoba offers products and services that address challenges across the entire mining value chain, we're here today to talk about electrifications. More specifically, we are here to talk about a simulation tool to help shorten the time between considering the purchase of a battery or electrified mining vehicle, physically testing that asset, and making the final purchasing decision. We all know that haul trucks and other mining vehicles are responsible for up to half of all mining CO2 emissions, and that many mining companies are looking to transition to battery electric options. However, there are many challenges on the path to electrification. We have been having conversations with mining clients and partners who have revealed common hurdles. Decision makers often rely on simple Excel sheets and OEM-specific tools. They juggle between tools, have to conduct multiple live trials. They have to repeat these trials for each potential asset. And complex operational and environmental factors are often oversimplified. Considering the assets and trials costs, the current lead times, operational and environmental complexities, and the interaction with the rest of the fleet, oversimplified models can turn what appears on paper as a good investment into a money pit. Having to optimize the use of the asset throughout its entire life adds another layer of complexity. This is where we come in. Our solution is not the silver bullet, but the accelerator towards it. That accelerator is an OEM agnostic simulation tool, which is currently at the proof of concept stage. To help streamline basic asset design, accelerate and de-risk the decision-making process, reduce costs, and provide confidence in choosing the right asset for your specific needs. We deliberately chose to keep the initial phase of the proof of concept simple, and we decided to start by replicating a day in the life of a single vehicle, the popular Volvo L120, traveling up and down a mine shaft in a 12-hour period in a partner mine, comparing a diesel version and a battery equivalent version. Obviously, in 7 minutes, we are not going to go into the details of how the simulation tool works. And I suspect many of you might actually switch off if I tried this. So instead, a picture tells 1,000 words. So I will now show you a brief video of the actual simulation tool in action. We started the simulation with a diesel truck model with its driver, environment, road components, and all essential vehicle components. The driver is actually modeled to sense the road and plan when to turn, accelerate, or brake, while the vehicle component is modeled to represent the real diesel truck. We applied a system thinking approach throughout to reflect how all parameters are connected and how they affect each other, and to help improve accuracy. Of course, although we did use numerous parameters in this simulation, more complex modeling of the engine component is available. And after we modeled the diesel version of the Volvo, we then moved to its electrical version. We used the same external parameters, but this time the Volvo was equipped with a battery, electric motor, and a regenerative braking system. So you might be thinking that this is all well and good, but what does this simulation actually tell us? Well, we chose to focus this initial phase of the proof of concept on a few specific outcomes, comparing EV to diesel energy consumption in real time, which you can see on both graphs at the top. This example also gives us a simple representation of uphill versus downhill, with a portion of the graph in green showing downhill and in red showing uphill. While it is not shown here, CO2 emissions as well as diesel particulate matters will be derived from this data. Also, similar to the engine components, a more advanced and complex battery can be modeled. And finally, an impressive 100,000 or so equations were used to solve the model, so not quite what that good old Excel sheet can do. In the next couple of weeks, these simulations will be further updated based on actual terrain data, speed profile, any sensor data we can obtain on the operating environment, and the payload carried up the hill. We will then expand outputs to include elements such as DPMs, heat, the impact of further environmental factors, the impact of refueling versus recharging, and life cycle costs. And as we gather more data from the battery OEMs, we'll then also be able to do a real comparison of the various battery technologies and their impacts on the asset's productivity. And this is only the beginning. Looking at a vehicle in isolation is clearly not sufficient, and a systems thinking approach is absolutely necessary to deal with the complexity of a mine, given its high number of vehicles and vehicle types. Central to all our simulations are, of course, the impact on productivity and on whole of life costs. We're now actively working on increasing the model's complexity to truly simulate the conversion of an entire mine. Our next planned modeling phases will look at the impact of the electrification of an entire fleet, and then of the mine as a whole, from a mining productivity, mining planning, and equipment maintenance optimization perspective. The simulations will in particular help determine which assets to electrify as a priority, how, when, and where to best recharge, taking into account all other electrified and non-electrified assets on site. Develop predictive maintenance to anticipate maintenance needs and reduce downtimes. Support battery life extension programs to ensure batteries are operated within their optimal range. And assess the mine site's electrical infrastructure to accommodate the increased power demands and recommend necessary upgrades. Of course, core to these simulations will be to ensure that mining operations run efficiently, reliably, and cost effectively, while considering the total cost of ownership throughout the asset's lifespan. This approach will help promote sustainability, reduce operational risk, and maximize the return on investment for electrification initiatives in mining. So, to conclude, relying on lengthy trials, OEM-specific tools, and basic spreadsheets risk being costly in time and resources, and risk misrepresenting the complexity of a real mine. This could then lead to the wrong assets being electrified, the wrong battery technology being used, or the wrong operating modes being put in place. So if you would like to see a glimpse of what your mine could actually look like in 2025 and beyond, and if you want to de-risk your decision-making process to get there, come and sit with us and we'll take you on your electrification journey. Over to you, Sam.
Thank you very much, Nadine. Fantastic presentation. That's the end of the presentations. We do have time for some questions now. I know these have been answered by the panelists directly to the question askers, but I'll just run through them again for the benefit of the whole audience. So the first one was directed to Melissa about the experiences that all mining companies and sites operate to different standards. How can a single platform support the contractor to work on multiple sites where there are still a different set of rules around site access, competencies, etc.?
No worries, thanks for that. So basically our platform allows the contractor to set up multiple client companies, work sites, jobs, etc., applying specific compliance requirements to each work site and company. So this includes specific job roles as well. So for example, in Go Site Ready, the admin for that contracting company can, in just a couple of clicks, see if their diesel fitter who is compliant on a Glencore site, based in Bulga, for example, based on Bulga's training matrix requirements, or indeed for any client of theirs. So further to that, because Glencore use our Go Site approved product, we have the ability to develop automations. So as in Carl's example as well today, so it was to submit at the click of a mouse updated certifications of those systems. Depending on the systems used by other clients and their appetite to integrate with our ecosystem, we're very happy to explore integrations in the future. But for now, we're focusing on what is within our control, and that is solving problems within the ecosystem. And whilst, we know that we won't be able to solve all the complexities between miners, let alone the struggle of complexities between mines at the same mine. PIAGO has the benefit and the local Australian-based expertise, working closely with our contracting companies to identify their frustrations.
Thank you very much, Melissa. Alvaro, is Aviva working with any site specifically on water or tailings?
Yeah, I was looking at my answer. Thank you, Sam. And yes, Janine, I think your question was from you. Yes, we are on water quality. We've developed solutions primarily on the PI system that allows you to configure alerts and events. I'll try to reach out with some customer presentation on the work they've done there on water quality themselves. On asset reliability, the solution that I presented a few minutes ago is really applicable for things like pumps of many types, as I put there in my answer, and also motors, and applicable for water treatment plants and the processing facilities within tailings operations. But yeah, I'll try to get some more specific content to share with you.
Thank you, Alvaro.
There was another question for me, Sam. If that's okay, I'll continue with that.
Sure.
Which is kind of looking at the big pictures, the 6 areas where mines generate value from Aviva products. What are the areas that deliver the best value? And I'm saying there in my answer that it really depends on the nature of the operations. We see some companies, for example, struggling with things like reliability, both for fixed assets and mobile assets, where we offer solutions for data management, analytics, condition-based monitoring. There are certain organizations that are looking to optimize production and see the value in pure dollar terms. So solutions like production management that help with downtime reporting, inventory management, sustainability is really important to them. And then we see other companies that have a strong ESG mandate, where things like real-time emissions monitoring, water treatment management are important for them from a reputational value perspective. And we have solutions for that as well. So yeah, worth a continued conversation there. Thank you, Sam.
Thank you very much, Alvaro. Nadine, one for you. What is the typical time taken to set up these digital models as opposed to testing them the old traditional way?
Hi, I just saw that. I was just typing an answer, so I'll just do a live answer. So it really depends on what level of complexity is required by the user. So, but when you look at really a full testing, like physically testing an asset, you're looking at saving up to 80% of the time that you would spend on testing that asset physically, which can all be done with a model.
Thank you very much, Nadine. If there's no more questions, then we will wrap it up. If there is a question you do have that you didn't think of during this time, we can reach out to the speakers. So let us know at Austmine and we will reach out directly to them and put you in touch with that respective speaker. Thank you to everybody who attended, and we look forward to hosting you again in the future. We do have some upcoming webinars as part of this ESG Showcase series. So if you did enjoy today's webinar, please continue the journey with us. There's a zero carbon mine coming up on the 11th of October and the small footprint mine on the 9th of November. A big thank you to all our presenters for their fantastic insights on the amazing technology our members have and sharing your expertise. Thank you, everybody. Have a good day.